All right, today we're taking our absolute value functions and we're going to look at them in some word problem situations, some things where they might actually occur in your everyday life or maybe in your future or in somebody's everyday life. So the first one we have here is about holograms. So in holography, light from a laser beam is split into two beams, a reference beam and an object beam. Light from the object beam reflects off an object and is recombined with the reference beam to form images on film that can be used to create three-dimensional images. Write an equation for the path of the reference beam. Okay, so looking at our problem, nowhere in there does it give us any specific information about points, where they're located, distances. There's no numbers in there, things that we're going to have to add to our graph. That's one of the things you want to look for. Does it give me any other information that my graph does not give me? What it does tell us is that we need to write an equation for the path of the reference beam. It talks about the reference beam. It also talks about an object beam, but what we're looking at for this problem is the path of the reference beam. So if we look at our picture over here, here's our laser. It shoots off. It comes up to the 0.58 where the mirror is, and then it comes back down. This part where it comes back down, that's my reference beam. So this is the area, or the part of my graph that I'm trying to write the absolute value function for. Since 0.58 is here at the tip, at the point, that would be our vertex. So as we go to write this equation, we're going to have a y equals, and we've got our absolute value. Right now, we don't know what our a value is. All we know is that it starts at 0, 0. We have a vertex at 5, 8. My vertex is telling me it's gone to the right 5 and up 8. We know from our previous look at transformations that that would tell me that because it goes right, we're going to have an x minus 5 on the inside, and it shifts up 8 units all from the origin. So we'd have a plus 8 on the outside. We still don't know what that a value is. We've talked about a couple different ways we can do that. So the first one we're going to look at is by plugging in a point. Looking at my graph, the only other point I'm given is down here is 0, 0. It tells me that's where my laser starts. So we know the point 0, 0 is also on this absolute value function. So if we plug 0, 0 into our function, we should be able to solve for a. So instead of y, we're going to plug in 0. Instead of x, we're going to plug in 0. And then the rest of it's going to be just like it was. So we'll have 0 equals a absolute value of 0 minus 5 plus 8. So all I did was plug in 0, 0 for my xy point. Now we just need to solve for a. So 0 equals a. 0 minus 5 is negative 5. So absolute value of negative 5 plus 8. The absolute value of negative 5 is positive 5. The big thing you have to pay attention here is this is a times the absolute value. There's not a sign, not a plus, not a minus in between a and the absolute value bar. So that means they're being multiplied. So this is not a plus 5. This is 5a because it's 5 times a plus 8. If we subtract the 8, we'll have negative 8 equals 5a. Sorry, that doesn't look anything like a 5. But we'll pretend. We solve for a. If we divide by 5, then we get a to be negative 8 fifths. That still hasn't given me my full absolute value equation, so we'll go back to our y equals equation. So we got y equals, our a value is negative 8 fifths. Inside my absolute value bars, we have our x minus 5, because we went right 5. Plus 8 because it went up 8, and there's the equation that models your function. From here, you could plug in a variety of points to see if they work. So if you wanted to know if the beam splitter, which is right here, if you want to know is that beam splitter at 2.5, 4, you could plug in the point 2.5, 4 into your equation, see if it's true, and you would know whether or not it lies on that line. The other way we can look at it is by using the slope or and just our general knowledge of transformations. So here's our graph again. Here's our laser beam. It goes up, it comes back down. Again, we know that we've got this point at 5, 8. So we know we've got y equals something absolute value of x minus 5 plus 8. We still don't know what that a value is. That's what we're looking for. What we've looked at from before is that we can look at the slope of the line of one of the legs of my absolute value, determine what the a value is, and then we look at the direction that our absolute value function faces, determine if it's positive or negative. So if we look at our slope, here we start at 0, 0. We also have the 0.58. These are two clear points, so they're ones I'm going to use. Slope is always rise over run. So this rise is 8 and goes over 5. So we know my slope is going to be 8 over 5. But when we look at this absolute value function, we see that it is facing down. Our parent function is a v. So since this has been reflected over the x-axis, it's facing down now. We know that my absolute value function, or my a function, my a value, sorry, is going to be negative. So because it's reflected down, we know this is going to be a negative 8/5. We'll put our y equals back in, and our x minus 5 in absolute value plus 8. Now, mathematically, stepwise, in the work you show, this seems much simpler. However, the biggest thing that's going to happen is you'll get so caught up in finding the slope that you'll completely forget to put this negative in. That is a significant difference between what this graph would look like if this was a positive 8/5 and a negative 8/5. So you really need to be careful. If you're going to go this route and visually look at it, determine the slope to find the a value, you've got to make sure you take that extra step and that extra thought to determine if it's going to be positive or negative. We're going to continue to do some more problems like this in class, where we'll look at some different situations and plugging in values, but that's the basic idea. Use the word problem you have, use the picture you have. Oftentimes the picture is not going to include all of the all of the information you need. So this one, it did have all of our information. It had our vertex point, it had another point, but many times that's going to occur in your word problem, and you're going to have to add that to your graph or your picture. So make sure that you are very thorough about what it's asking for and what information you're given.